To build a program, we need two kinds of elements. We need basic actions, basic instructions, which we've started to see and we will see more, like assignments, for example. And we also need ways to combine these actions into actual programs by defining the sequence in which these basic actions will be executed at runtime. Such structures which define the sequencing of operations during the execution of the program are known as control structures. And in this lecture we are going to study the fundamental control structures of programming plus a few important supporting concepts. We are going to focus on three fundamental kinds of control structure: the compound, the conditional, and the loop. The compound tells us do A, then do B, then do C, then do D. It's also known as a sequence. The conditional tells us either do A or do B depending on a certain condition. And then the loop tells us do A certain number of times, maybe many times, maybe millions of times. Of course, computers are very fast, so they can repeat a sequence of operations many times until, for example, a certain condition is met. So these are the three fundamental control structures: the compound, the conditional, and the loop. We will see a number of important supporting concepts, in particular for loops, the notion of loop invariant and the notion of loop variant, which help us to reason formally, mathematically, logically about our programs and their correctness. The variant in particular is there to convince ourselves that a particular loop, and hence the program in which the loop appears, terminates. That's of course a very important question. We want our programs to terminate after a finite time. How do we know? And for example, we are going to ask the question, can we indeed know ahead of time? Can we have a mechanism that enables us to determine whether a certain program will terminate at all or not? This is known as the halting problem, and the answer to that question, do I know whether my program will terminate? Can I know whether any program will terminate? The answer is going to be pretty surprising. So, welcome to this lecture on control structures and the supporting invariant and variant mechanisms, as well as the halting problem.